Okay, so get this up. What do we got here? So we got the stress strain plot for a typical, something like say a mild still. And some features that we need to look at is, you notice this is the elastic limit. So when I release the load that I'm going to apply, we expect the material to go back down this line here, and we can keep doing this as many times as we like, as long as we don't suffer from fatigue. And our elastic limit is measured by the yield strength. So up to that point, that's the maximum stress I can apply to the elastic limit. Okay, so that's the yield point here. And that's where we'll only be looking at. Other stuff you can see is the fact that you're going to have the Young's modulus there. So Young's modulus, which will be the stress over the strain. So you could use the yield strength here and the yield point here. This point here is called the ultimate tensile strength. So we can't get a stress more than that. If we did apply a stress more than that, it would automatically fracture. The reason why it now seems to start doing something a bit weird when we stretch it even longer, the stress in actual fact drops. The reason for that is actually stress is not dropping as you're pulling it more and more apart. What is happening is that your area in a certain point where it's about to fracture is getting smaller and smaller. So the area that you're using to work out your stress is not really the correct stress. It's actually has a higher value than it would actually appear to be what you're applying, because your stress that you're plotting here is the force divided by the original cross-sectional area, not the area where it's starting to get thinner and thinner. So that's why it starts to drop. Right, so that's just a little introduction to a stress strain plot and some of the features of it.